So good morning everyone. I am Precious Elda Bandan and I will be teaching grade 8 mathematics. So today, I will be teaching you about illustrating functions and relations. So at the end of this video, you will be able to first illustrate a relation and a function. Second, verify if a given relation is a function. Third, relate function to real-life situations. I know you are all excited about our lesson, but before that, let us have a quick review about the coordinate plane. You're going to identify the coordinates of a given point on the coordinate plane. So point A, what is the coordinate of point A? 0, 0, very good. And point A lies on the origin. How about point B? It is 1, 3, very good. How about point C? Point C lies on the x-axis. So its coordinate is 4, 0. How about point D? -3, -2. Correct. Point E, -2, 3. Now, let's proceed to our next activity. Activity is called Pick Math Word. In this activity, you are going to form a word out of the given pictures and patterns that serves as a clue. You have only given 3 seconds to answer. Number 1. So the word is domain. Very good. Number 2. So the word is range. Number 3. The word is one-to-one. Nice. How about this one? This is one-to-many. This one, many-to-one. Next, this word is mapping. Very. How about this one? The word is table. Next, this is function. Very good. And last, this is a relation. To begin, let us start our lesson with the word relation. So when you hear the word relation, what words or phrases comes to your mind or ideas? Okay, a relation is something to do with a connection or association between things, like people and others. For example, mother and child, teachers and students, schools and teachers, and so on. So the concept of relation, it involves the pairing and association with the elements it is associated with. So in math, we have also a number who describes a relation, and we call it a relation. So a relation is a set or collection of ordered pairs, like this, for example. So all these sets are pertaining to relation. Relation is composed of ordered pairs, and an ordered pair consists of components of the arrangement, which affects the essence of relation. So we have the domain. It is the set of all first element of the ordered pairs, and also known as abscissa. Next, we have the range. It is the set of all the second element of the ordered pairs, and also known as ordinates. So let us have this first example. First, we're going to determine the domain. Remember that the domain is the first element in an ordered pair, or the x values. So these are 3, 2, 0. Next, we have the range. The range is the second element in an ordered pair, or y values. So 5, 7, and 5. Let's have the second example. We have here the set of ordered pairs 1, 2, 3, 5, 2, 7. So first, let us determine the domain. Take note, in writing a finite set, elements should enclose with the curly braces. So we have here 1, 3, 2. So the domain consists of 1, 3, 2. Next, the range. The range is the second element in an ordered pair, or the y values. So we have 2, 5, and 7. So the range consists of the elements 2, 5, 7. Since we already determined the domain and range, let us put this into an arrow diagram called mapping. So mapping is a representation of two sets of objects with an arrow drawn between them to show the relationship between the objects. So how to represent a relation by mapping? Let's have this example. So we have here the set containing the ordered pair 5, 2, 3, 6, 1, 7. So first step in mapping, we need to identify the domain and range. So the x values here are 5, 3, 1, and the range 2, 6, 7. Second step is we're going to draw two oval shapes. Left oval shape is for your x values or domain, and right oval shape is for your y values or range. Fill in the domain and range to their designated shapes. And lastly, draw an arrow that connects each element of the domain to each element of the range. 3 to 6, 1 to 7. In our mapping, each element of the domain is paired exactly one element of the range. Next, how about we represent a relation using table? So like mapping, let us first identify the domain and range. So in this example, the set containing the ordered pair 5, 2, 3, 6, and 1, 7. First, let us find the domain. The domain are the x values. So 5, 3, and 1. Next is the range. 2, 6, and 7. Second step is we're going to create a two-column table that represents our domain and range. Lastly, we're going to fill in the domain and range to their designated shapes. So there you have it, the representation of relation using table. Now, let us have a graphical representation of relation. So wherein we're going to use a Cartesian plane to plot the points in the given relation. So in this example, that is going to plot the given points. So 5, 2 is in here. Next, the point 3, 6, and 1, 7. So there you have it, the representation of relation by graphing. In general, each relation can be represented any of the following. So by listing, by mapping, table, and graph. So another example, the set containing the ordered pair red, blue, red, yellow, and red, orange. So as you noticed, we have the same domain, which is red. So we're going to write the domain once. So the domain is the set containing red. Next, we have the range. So we have the blue, yellow, and orange. If we're going to map the given, we're going to use the same procedure. First step is we're going to identify the domain and range. So the domain is red. Next, the range, blue, yellow, and orange. Second step is we're going to draw two oval shapes. So left oval shape is for the domain or the x values. And right oval shape is for your y values or the range. So we have blue, yellow, and orange. Lastly, we're going to draw an arrow that connects each element of the domain to each element of the range, to each corresponding ordered pair. So red, blue, red, yellow, red, orange. Next is a table form. Like the example earlier, we're going to identify the domain and range. Then we're going to create a two-column table that represents our domain and range. And lastly, we're going to fill in the domain and range to their designated shapes. So in general, each relation can be represent any of the following. So by mapping and by table. Now let us have our third example. So the set containing the element of the ordered pair 0, 4, negative 3, 4, 1, 5, negative 8, 4, and negative 1, 5. So first, let us determine the domain. The domain are the x values or the first element in an ordered pair. 0, negative 3, 1, negative 8, and negative 1. Next, the range are the y values. So 4, 4, 5, 4, and 5. So take note, in writing a domain or the element, we use a curly braces. So the domain are 0, negative 3, 1, negative 8, and negative 1. Next, the range, we have 4 and 5. Next, let's represent this example into mapping. So first, let us identify the domain and range. Second step is we're going to draw a two oval shape. So left oval is for your domain and right oval is for your range or y values. Next, we're going to fill in the domain and range to their corresponding shapes. And lastly, we're going to draw an arrow that connects each element of the domain to their designated or corresponding ordered pair. Now, let us represent this example into a table. And again, let us identify the domain and range. Next, we're going to draw a two-column table, which represent x and y. So X is for your domain and Y for your range. Next, we have the graph. So we're going to plot the given points into our Cartesian plane. So 0, 4, -3, 4, 1, 5, -8, 4, and -1, 5. In summary, since we have already discussed the different ways to represent a relation, now we are going to identify what type of relation they are belong to. So first type is one-to-one. Every element of the domain is paired with a unique element of the range. Our example number 1 is an example of one-to-one relation, since every element of the domain is paired with exactly one element of range. Now, let us another example in real-life scenarios. Number 1, one mayor per city. So, we have Mayor Joy for Quezon City, Mayor Isko for Manila, Mayor Vico for Pasig City. Next, capital city of a country. So we have Manila for Philippines, Tokyo, Japan, Seoul, Korea, Rome to Italy. Next type is one-to-many. Every element of the domain is paired with a unique element of the range. Let us have an example number 2, which describes a one-to-many relation. Since our domain is paired with more than one element of the range, so it is classified as one-to-many relation. Let us have one-to-many which applied in real-life situation. Miss Perez and her 3 students, Kaloy, Anne, and Jane. So the relation of the teacher towards her students. Miss Perez to Anne, Miss Perez to Jane. So that is an example of one-to-many relation. Next, the relation of our sun to the planet is one-to-many relation. So sun to Jupiter, to Mars, to Earth, and to Saturn. The third type of relation is many-to-one, a relation in which more than element of the domain is paired with the same element of the range. So in example number 3 a while ago, it describes many-to-one relation because 2 or more than elements of the domain is paired with the element of the range. Another example for real-life scenarios in many-to-one is the collaboration of 8 subject teachers to a students. So X values for the subject teachers and Y values for the student. So this is an example of many-to-one relation. There you have it, the different types of relation. And this time, let us test your ability in identifying the types of relation. By this activity, you're going to describe the type of relation by the following real-life situation. So we're going to use these emojis for your answer. So heart shape for one-to-one, thumbs up for one-to-many, and wow reaction for many-to-one. Also, you can pause this video if you need enough time to think about your answers. Number 1. Student and LRN. Is it one-to-one, one-to-many, or many-to-one? So the answer is heart shape, one-to-one. Did you get it? Very good. Next, number 2, President and his countrymen. Is it 1-to-1, 1-to-many, or many-to-one? The answer is 1-to-many. Number 3, driver and his driver's license. Is it 1-to-1, 1-to-many, or many-to-one? The answer is 1-to-1. Number 4, utility bills in-house. Is it 1-to-1, 1-to-many, or many-to-one? So the answer, it is many-to-one, since we have different utility bills in a single house. Number 5, 3 main largest islands of the Philippines. Is it 1-to-1, 1-to-many, or many-to-one? The answer is many-to-one. Very good. As we continue our topic, did you know that there is a special kind of relation? The special kind of relation is called function. Function is a relation in which each element of the domain corresponds to exactly one element of the range. So it is a special kind of relation because it follows an extra rule. Like relation, a function also has a set of ordered pair. However, every x value must be associated with one y value. So keep in mind that every function is a relation, but not all relation is a function. Functions can be represented by different ways. So it can represent by listing the set of ordered pairs, by table, by graphing, and even in an equation. So for example, in this example, we have the elements containing the ordered pair 0, 1, -2, 2, and 3, 4. So first, let us identify the domain. The domain, again, it is the x values. So we have the elements 0, -2, and 3. Next, we have the range. The set containing 1, 2, and 4. So in this example, each domain is paired with exactly one range. So it is 1-to-1 relation. And by definition itself of a function, it is a function. For our next example, the set containing the ordered pair -3, 1, -4, 1, 2, 4. Observe that one domain is paired with two elements of range, which is 1. Okay, so our domain is -3, -4, and 2. So our range is 1, 4. So this is a one-to-many relation. And by definition itself, it is not a function. Next example, we have the set containing the ordered pair 5, 3, 5, 1, and 5, 9. So if we are going to observe, we can see that the domain is paired with more than one range. Okay, so the domain is 5. The range is 3, 1, 9. Okay, so Therefore, this is many-to-one relation. And by definition of a function, it is a function. Let us analyze this. If our relation is ordered pair is 1-to-1 and many-to-one, the relation is a function. While if the relation is 1-to-many, then the relation is not a function. Now, let us go to this activity. You are going to identify if the following mapping or table is a function or not a function. Okay, number 1. Is it a function or not a function? It is a function. Very good. Next, number 2 given. Is it a function or not a function? This is a function. Very good. So, this is a function because the relation is many-to-one. Next. Number 3, is it a function or not a function? This is not a function. So in graph, how do we determine if the relation is a function? So we use a vertical line test. To use this, simply throw a vertical line passing to the graph of the relation, and then observe the point of intersection. In the given example, no points lie in a vertical line. So this means the graph is a function. Another example, when we draw a vertical line, it passes through and intersects exactly 1. So therefore, our graph is a function. Another example. So using a vertical line test, let's see. So it intersects exactly 2 points in the vertical line. So this means the graph is not a function. So let's do this activity. You're going to determine the domain, range, type of relation, and decide whether the following given is a function or not a function. You can also pause this video if you need time to think of your answers. Number 1. So the domain are -3, -2, -1, 0, and 1. Next, the range. -2, 0, 2, 4, 6. And the relation, it is 1-to-1. Is it a function? Yes. Next, number 2. So the domain are -1, 7. And the range, 0, 5, and 2. The relation, it is many-to-one. Is it a function? Yes, very good. Next, number 3. The given is the graph. So the domain are -2, 1, 4. The range, 3, 4, 1, -1. And the relation, it is 1-to-many. Is it a function or not a function? No, it's not a function. And also using a vertical line test, it intersects the 2 points in a vertical line. To fully test if you understand the lesson, do this activity. Write your answer in one whole sheet of paper. And for your assignment, answer this one. Complete me up. You're going to use the given ordered pairs to complete the table and values, to draw its graph, to illustrate the mapping, and to generate its rule. The first two values are done for you. Okay? So your evaluation and assignment will be collected in the next retrieval. I hope this video helps you to understand the lesson. Thank you and see us again to our next video lesson.